Hi everyone, this is Alex. In today's video, we are going to look at two very important rules in differentiation, the product rule and the quotient rule. So far, we worked with these two box methods. But sometimes a function is made up of two separate parts, being multiplied together, or one function divided by another. In those situations, we need a different approach. Let's begin with a simple question. Suppose we have a function written as a product of two functions. How do we differentiate it? A very common mistake is to think that the derivative of the product is just product of the derivatives. In other words, some students think that the derivative of uv is simply u prime times v prime, but that is not correct. So what we need here is the correct rule for differentiation of the product of two functions, and that is exactly what the product rule gives us. Now let's take a look at where the product rule actually comes from. We start from the first principles. Now suppose f of x is u of x times v of x, then f of x plus h is u of x plus h times v of x plus h. So if we substitute these into the first principles, we get f prime of x is limit as h approaches 0, u of x plus h times v of x plus h minus u of x times v of x over h. At this point, the expression in the numerator is difficult to separate directly. So we use a common algebraic trick. We add and subtract the same term inside the numerator. So the expression becomes limit of u of x plus h times v of x plus h minus u of x plus h times v of x plus u of x plus h times v of x minus u of x times v of x over h. Now we group the terms in a useful way. From the first two terms, we can factor out u of x plus h. From the last two terms, we can factor out v of x. So this becomes limit of u of x plus h bracket v of x plus h minus v of x and plus v of x bracket u of x plus h minus u of x over h. Next, we separate the limit into two parts. And it will be limit of u of x plus h parentheses v of x plus h minus v of x over h plus limit of v of x times u of x plus h minus u of x over h. Now let's look at each part carefully. As h approaches 0, limit of v of x plus h minus v of x over h is v prime of x, because that is exactly the definition of the derivative of v. Similarly, limit of u of x plus h minus u of x over h is u prime of x. Also, u of x plus h approaches u of x as h approaches 0. So the whole expression becomes u of x times v prime of x plus v of x times u prime of x. Rewriting this in a useful order, we get u prime of x times v of x plus u of x times v prime of x. A simple way to remember the product rule is this. Differentiate the first, keep the second, then keep the first, differentiate the second. It is important to notice that there are two terms, not one. So in a simpler form, to differentiate the product of the box and a rounded box, first differentiate the box and keep the rounded box the same, and add the box and change it, multiply by the derivative of the rounded box. Next, let's look at a slightly more advanced example. We have y equals 2x cubed minus 1 times square root of 5x plus 2. Using the product rule, this becomes dy by dx is 2x cubed minus 1 prime times square root of 5x plus 2 plus 2x cubed minus 1 times square root 5x plus 2 prime. And for square root 5x plus 2, using the box method for square root, we can just put 5x plus 2 into the box. So its derivative will be 5 over 2 square root 5x plus 2. So dy by dx is 6x squared times square root 5x plus 2 plus 2x cubed minus 1 times 5 over 2 square root 5x plus 2. Now, to combine these two terms, we need a common denominator. So for the first term, I multiply by 2 square root 5x plus 2 over 2 square root 5x plus 2. Since I'm multiplying the numerator and denominator by the same expression, the value does not change. So the first term becomes 6x squared square root 5x plus 2 times 2 square root 5x plus 2 over 2 square root 5x plus 2. And the second term simplifies to 10x cubed minus 5 over 2 square root 5x plus 2. Now both terms has the same denominator, so we can combine them. 12x squared times 5x plus 2 plus 10x cubed minus 5 over 2 square root 5x plus 2. Next, expand the numerator, so we get 60x cubed plus 24x squared plus 10x cubed minus 5 over 2 times square root 5x plus 2. Finally, combine like terms, so dy by dx is 70x cubed plus 24x squared minus 5 over 2 times square root 5x plus 2. So this is our final answer. Finally, let's work through a more exam-style product rule question. Let's summarize the key idea. We use the product rule when two functions are being multiplied together. If y is u times v, then dy by dx is u prime v plus u v prime. A quick way to remember it is differentiate the first, keep the second, and keep the first, differentiate the second. So whenever you look at a question, the first thing to ask is whether the function is written as a product of two parts. If it is, then the product rule is likely the right tool. Now that we know how to differentiate a product, let's move on to another very common structure, a quotient, where one function is divided by another. In this kind of question, the function is no longer a product. It is a quotient, which means one function is over another. For that kind of structure, we use the quotient rule. One nice thing about the quotient rule is that it can be derived from the ideas we already know. Suppose f of x is u of x over v of x. We can rewrite this as u of x times v of x to the power of -1. Let me just bring up the product rule and a box method here. Using the box method for v of x to the power of -1, we put v of x in the box and take n equals -1. So the derivative becomes negative box to the power of -2 times box prime, and in this case, box prime is v prime of x. Now we can differentiate using the product rule. So f prime of x is u prime times v to the power of -1 plus u times negative v to the power of -2 times v prime. Simplifying this expression, this will be u prime over v minus u times v prime over v squared. If I rewrite this in a single fraction, this becomes u prime v minus u v prime over v squared. A useful way to remember this is differentiate the top, keep the bottom, minus keep the top, differentiate the bottom, all over the bottom squared. Then you can see that the numerator is almost the same as the product rule, except that the plus sign in the middle becomes a minus sign. So unlike the product rule, this time we are working with the numerator and the denominator, and the order matters. Now we have a different example of y equals x squared plus 1 over square root 3x plus 2. By using the quotient rule, dy by dx is x squared plus 1 prime times square root 3x plus 2 minus x squared plus 1 times square root 3x plus 2 prime all over square root 3x plus 2 squared. Now let's differentiate each part. To differentiate square root 3x plus 2, we'll use the box method for square root. Here the box is 3x plus 2, so the box prime is 3. Therefore, its derivative is 3 over 2 square root 3x plus 2. Then dy by dx becomes 2x times square root 3x plus 2 minus x squared plus 1 times 3 over 2 times square root 3x plus 2 over 3x plus 2. Now to combine the two terms in the numerator, so I multiply by 2 times square root 3x plus 2 to top and the bottom. So nothing has been changed since I multiplied the same value top and the bottom. So we get 4x times 3x plus 2 minus 3 times x squared plus 1 over 2 times square root 3x plus 2 by 3x plus 2. By expanding the numerator, this becomes 12x squared plus 8x minus 3x squared minus 3 over 2 times 3x plus 2 to the power of half by 3x plus 2, which simplifies to 9x squared plus 8x minus 3 over 2 times 3x plus 2 to the power of 3 over 2. That's all for today's lesson. Thanks for watching, and I will see you in the next lesson. This has been Alex.